Hello, let's continue our Sudoku adventure with Lots of Blue by GDC. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So within each box, the cells on the line have the same sum. Another way to put that would be if we take this line, we can segment it by the box borders. So this would be one segment, this would be another segment, this would be a third segment. Let me color that. So like green, purple, yellow. So we have the green segment, the purple segment, the yellow segment. It's segmented by box borders. Now the sum of the green digits has to equal the sum of the purple digits, which equals the sum of the yellow digits. Now this would also get segmented like blue and red, and then this would be on its own, maybe gray. Blue does not have to equal green because it's not on the same line, but these lines all work internally. So blue has the same sum as red, which is equal to whatever digit is in this gray. So that is region sum lines. Let me just clear that all out. We also have odd lots and even lots. Now, I got some confusion last time. These are circles and these are squares. That does not mean we have to put an even in the square and an odd in the circle. These are not even, odd, square, circles. They're odd lots and even lots. So what they do is they count. So in this case, this odd lot counts the number of odd digits on the entire line, including itself if it happens to be odd. But I could put a 4 here if I wanted to. And if I put a 4 here, then that means that there are in total 4 odd numbers on the line, including itself, but it's not odd, so it doesn't matter, right? So there'd be some number of odds equal to 4 on this line. But I could also put a 3 here, and then that would mean that including itself, there are 3 total odds, and so it counts as one of them. And then even lots are the same, they just count the number of even digits on the line. So if this was, say, a 3, then that means there's 3 even digits on the line. That's perfectly allowed. It doesn't have to be even itself, but if it is even itself, it does count itself. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so the first thing I noticed is that this actually tells us the sum, which is quite handy. Now, why does that tell us the sum? Well, a digit can only be even or odd. It can't be some other third option. So if we take the count of the digits on this line, 1, 2, 3, 4, 5, 6, 7, there are 7 digits on this line. We have to split them up into evens and odds, which get placed here and here. So the sum of these two will be 7 because there are 7 total digits that they're counting. This counts some number of odd digits, this counts some number of even digits, and in total they're counting 7 digits. So I know that 7 and 3 can only be represented as 1, 2, 4. Now, unfortunately, 7 here could be 1, 6, 2, 5, or 3, 4, but maybe we're limited. Okay, yeah, let's think about it this way. So we can try to count how many evens and odds we have, or at least get some ballpark. So we know 1, 2, 4 has 1 odd and 2 evens, so we already have that count. We know these add to 7, right? So 2 digits adding to 7, we need 1 even and 1 odd, because 2 evens would be even and 2 odds would be even. So an odd plus an even is the only way to stay odd, or to be an odd sum. 7 is odd. So there's an odd and an even here, and then these sum to 7 also, so there's an odd and an even here. So if we want to count the odds, there's 1 here, 2, 3. There are 3 odds, so we put a 3 here. That does count itself. And then this is a 4 to add to 7. There are 4 evens. So that places the 4 there. That's really neat. All we know is these add to 7. We don't know much more about that. I'm not going to film more. Let's think about this line next. Let's just go down the line here. So this is interesting because we know that this counts the number of odd digits. So there's 1, 2, 3, 4, 5. There are 5 total digits on this line. So it can't exceed 5. But if it was 5, then this would have to be 0 because this plus this are the total number of digits on the line, just as we talked about over here. This is the number of odds. This is the number of evens. If you add those together, that should get 5. And so this needs to be lower than 5 in order for these two to add to 5. But we can't be 4. So, and if we were tried to be a 2, that means these two need to add to 2 and these two need to add to 2, and then we can't do that. We can't repeat the 1. So this actually has to be a 3, and these are both 1, 2 pairs. But we know this is the 2 because there's 2 evens in these 2, 1, 2 pairs. So we get these digits. Very nice. Now I suppose we should think about this line. So These two, 1, 2, 3, 4. Yeah, there's 5 here. These two add to 5. So let's start with 1, 2, 3, 4. This can't be 1, 2, which means this can't be 3, 4. So these two add to 5. I'm skeptical of this being a 1. So if this was a 1, this would be a 3. Because that's just very restricting. We'd have to be all evens here. Okay, I see why that doesn't work. Yeah, that definitely doesn't work. Because this sum equals this sum. But this would be 2 even digits, and this would be 2 even digits plus 1, which would be odd. So this would have an even sum, and this would have an odd sum, and that doesn't work. So this can't be 4, 1, so it has to be 3, 2. Adding to 5. No. This is... Oh, the 4 looks down, putting the 4 here. So this adds to 7, so this has to be 1, 4 in this order to add to 7 as well. Now, the only thing other than Sudoku we have is that this adds to 7. Can't be 3, 4. So it's either 1, 5, which would go 5. Sorry, not 1, 5. It would be 1, 6, which would put 6 here and 1 here, or 2, 5, which would put 5 here and 2 here. Hopefully Sudoku will tell us which is which. Let's just start filling out. So this is a 5, 6 pair. That's a 3. This is also a 5, 6 pair. We get a 3 in the corner though. Duty. This is a 5, 6 pair. So here we need a 1 and a 2. We know the order. That's 2 and 1. And that gives us the 6 and the 1 adding to 7. Very nice. So that's 2 and 1. Oops, 2 and 1. This is 5. This is a 5. That's 6 and 5 because we had a 6 in the box. Here we need a 2 and a 4. Here we need a 5. That gives us 6 and 5. And then over here we've got a 3 and a 6. Now, let's just see what we need here. We have a 2, so we need the 3 and the 5. That's 5 and 3. That's 6 and 5. And then down here we need 4 and 6. That's 6 and 4. And we're done. Very nice. That was a neat puzzle, do you see? I liked the concept of putting both an odd and even lot on the line, which then made us know what the sum of those two cells was, and that was helpful each time, and it was done in a different way. Each line demonstrated a different way that could be helpful. This was very direct, in that now we know what the sum is of each segment on the line. Here, a little bit more indirect, in that these two had to add to 5, so that restricted what this could be, because it also controlled the sum of the segments. And then here, these had to add to 5, but 4, 1 didn't work because that would make this add to an odd number and this add to an even number. That was really neat. So I hope you enjoyed this as well, and if you did, then why not leave a like, subscribe, and a kind comment below.